Now, what does this have to do with randomized algorithms? And of course, any analogy can be criticized at one point or the other, but I think it fits rather well. If you use a randomized algorithm without having any guarantees, well, first of all, at a certain point in time, you have to determine that it's the last round. You're not running the algorithm any further. You've run it 200 times, 2,000 times, but then at a certain point, you just have to say, okay, this is it. This is going to be the result that I use. And it might be that the last 400, 500 times, or in this case 40 times, the algorithm has not found a better solution. It has found one that seems very good, and the solution has not improved. So at a certain point in time, you're just going to decide, well, it's likely that this is a very good solution. Now here's the thing where the analogy actually does not hold, because if you think about it, when we're dealing with an NP-complete problem, the chances of winning are not 5/6 over here. Indeed, we're playing a game with exponentially small probability of winning. So it's like this. When you run a randomized algorithm without guarantees, you're playing a game with bad odds. You don't really understand what's going on. And in the end, even though you run the algorithm multiple times, you only have one shot of getting it right at the point that you decide to stop your algorithm. So, should you run a randomized algorithm without any guarantees? I think the rules are almost the same as the one for this game here. So, if the stakes aren't very high, so the problem you're trying to solve is maybe not that important, and you're willing to take that risk, then you can do it, and sometimes it's the only possible way. But I think that an algorithm with guarantees is almost always preferable. First of all, you know what's going on, and secondly, and I think that's also very important to emphasize, in order to get these guarantees here, you have to construct an intelligent algorithm. So rather than just poking all the way around, you're poking intelligently. It's almost the same as with a search tree. So just using randomness in a way is brute force, only that in this time it's random force. And I think the name already says how powerful that is. But when you have guarantees, you're directing that random force in a certain direction. And that, of course, tends to improve your results dramatically.